Okay guys, so here's the video for the midterm study packet. Some of the questions that you asked me about on the Zoom meeting today, so we'll take a look at that. Okay, so we do have number 7, 10, 15, 17, and 27. So we'll take a look at each one of those. Okay, so started off with number 7. So find a polynomial p of x of degree 4 with integer coefficients and zeros 3 minus 3i and 2 with 2. A zeros of multiplicity of 2. Okay, so I think there's a typo here. So degree 4. Again, this one is for number 7. And with the zeros, so we do have 3 minus 3i. Okay, so we do have 2. Well, this one's supposed to be okay, so 2, that means that appeared twice. So multiplicity. So that appears twice. So we do know that's like x minus quantity of 3 minus 3i. So guys, keep that in mind. The conjugate of the imaginary number, it's also part of the solution. So it's x minus 3 plus 3i. And then x minus 2. So how many times does that appear? So that's saying that is twice. And also this one, you can find the, well, we do know that the coefficient is going to be integer. So that means there's a here. So that one is going to be one of those integer. We'll find out. Okay, so first thing that you want to do, you want to regroup this. So it's x minus 3. And then plus 3i. Because negative times negative, that's positive. And then this one, regroup them. So x minus 3. And then minus 3i. And this one is just x minus 2 quantity squared. So once you expand it, so it's x squared plus 4x. Minus 4x. And then plus 4. It's a perfect square trinomial. And then the rest of this, you can use the conjugate or the difference of two squared formula. So x minus 3 quantity squared. So 3i times negative 3i, then that'll be negative 9i squared. Okay. And then the rest of this, so you want to expand it. So x squared minus 6x plus 9. So negative 9i squared, that's plus 9. So plus 9. And then the rest of this, you want to multiply it out. So once you FOIL this, you end up with the one of those equations. Okay? So a, we do know that's an integer, so that means it's going to be 1. Okay, for the coefficient. Okay, so basically this one is just FOIL or multiplied it out, you'll get that. So now, what about for number 10, 15, 17, and 27? So we'll take a look at that. So for number 10. So we got number 10, then 15, 17, 27. Okay, so now if you look at that, number 10. So number 10, that's expressed the equation in logarithmic form. So e to the power of x plus 2 equals 0.2. So the way to solve for x, so you want to take that natural log both sides because that the base is an irrational number. It's a constant base. So natural log of 0.2. And then natural log of e, that just gives you 1 power. We can bring it down. So x plus 2 equals natural log of 0.2. And then solve for x. So natural log of 0.2 minus 2. So this one is actually pretty basic. So this one's for number 10. Okay, so now let's see what else that we have. So we got 15. Okay, so number 15. So the graph of f and g are given. Find a formula for the function of g. So this one is just about the transformation. Okay. So find the formulas of function g. So given that f of x is absolute value of x. So we do know that the transformational form for this one is considered a, absolute value of x minus h quantity squared, there's no square, absolute value of x minus h plus k. So according to the graph, this one shows the slope. If you just count the slope here, so this one will give you the rise and the run. If you just count it, looks like the run would be considered 1. And then the rise is 1, 2, 3, 4, 5. Looks like 5. Let me count it. 1, 2, 3, 4, 5. Yeah, right here. So this one is about rise over run. So that means A is 5. And then times absolute value of x minus 0, quantity, and then plus 0. So that means for g of x. So that one is just consider 5 times absolute value of x. So that one is not that bad either. It's just about the transformation with the vertical stretch, the scale factor. And then what about for 17? So 17 is about compositioning. So we'll take a look at that, 17 and 27. Okay, so 17 and 27. Okay, so for number 17, so use f of x. So that equals 2x minus 6. It's linear function. And then g of x. So 5 minus x squared to evaluate the expression. So we do have f of g of 1 for part A. And then for B, we do have g of f of 1. Inner function, outer function. So for the first part of this, you want to start it with g of 1. So plug in a number. So we got 5 minus 1 squared. So then that'll give you 4. So f of 4, then that's 2 times 4 minus 6. So this one, it's not that bad. So 2 times 4, that's 8 minus 6, then that'll be 2. And then for g of f of 1, so we do have g of f of 1, so 2 times 1 minus 6. So evaluate this first. So 2 times 1, that's 2 minus 6, so it's negative 4. So g of negative 4, so 5 times 5 minus negative 4 quantity squared. So it's 5 minus 16, then that would be negative 11. Okay, so it's not that bad for 17. And then 27. Okay, so if you look at that, 27. So 27, let's see, what is that about? Use definition of logarithmic function to find x. Okay, so we do have part A, part B. Okay, so this one is about using the special property of logarithm. Okay, so 27. Okay, we'll take a look at that one. 27. So part A. So this one shows that log base 3x equals 4, and then you want to solve for x. And then for part B, so that's log base 10, 0.00000. Let's see how many zeros that we have. 1, 2, 3, 4, 5, 6. 1, 2, 3, 4, 5, 6. Okay, 6 zeros. Okay, small decimal, so that equals x. So you want to solve for x. So this one, obviously, we can convert it back from log to exponential form. So the base is 3, and then the power, which is 4. So 3 to the power 4 equals x. So 3 to the power 4, so multiply by 3 4 consecutive time. So we get the value of x, so it's 9 times 9, which is what, 81. And then for this one here, we can use that the change of base formula. So this one, we can use the change of base, and also we can use that taking 10, base 10 on both sides. So one thing that we notice, so 10 log base 10, this one is just considered 1, so this one, that turns out to be 1. So 1 times this whole number, so it's 0.000001 equals 10 to the power of x. So that means this one you want to convert that to a small number. So, and also this one can be written as 10 to the power of negative 1, 2, 3, 4, 5, 6 decimal places, because that's 6 zeros. That means x is negative 6. Okay? So it's not that bad, you know, for all this. So make sure that you guys need to finish this study packet and review all your notes. Okay, so all the video that I put up there, make sure that you watch the YouTube channel, and also do all the practices, the ones that I sent out, well, all the book work, and also the midterm study packet, and also the previous study packet. Okay, so always check your binder, all the stuff that you have so far from chapter 1 to chapter 4. Again, the majority of the stuff for the midterm is going to be all chapter 4, and then the other 40% of the material is going to be from the other chapters. Okay, so, and for the next video, I'm going to put up some of the sample questions for the midterm. Okay, so thank you for watching the video today.